problem number 4. A fair coin is flipped 10 times. How many ways are there to flip more heads than tails? Alright, well, I'm going to show you a couple different ways to do this. So, first thing I'm going to do is, so let's say that we're recording the flips as they happen. So we'd put the first flip here, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Okay, we're going to flip it 10 times and then we'll record as we go along. So if we get a heads in the first flip, we just put an H here. And if we get a tails in the second flip, we put a T. Okay? So let's think about it that way. So more heads than tails. Alright? Well, we've got 10 flips, and so to get more heads than tails, we'd have to have at least 6 heads, right? So we could have 6 heads, or we could have 7 heads, we could have 8 heads, or 9 heads, or 10 heads. Okay? So those are all the cases that we could look at. Alright, so the number of ways that we could get 6 heads is sort of like, you know, if we call H a head, then, you know, we're looking at these 10 places here, and there's so we have 10 choices to put the first head. You know, it could occur on the second, and the fourth, and the fifth, and the sixth, and the 8th, and the 10th, or something. You know, it can happen on you know, any number of flips. You know, if this is the first flip, this is the second, third, fourth, fifth, sixth, seventh, 8th, 9th, or 10th flips. Okay, so so you can think of it as you know, we have 10 places to put the heads, and then the rest are going to be tails, right? Once we get the 6 heads placed in these 10 slots, then we'll have then the rest will just be filled in with tails, right? Because there's only 2 things that can happen. It's only either a head or a tail. So we can actually write this as 10 choose 6. Okay, which means we have 10 choices for the first, you know, for the first position of a head, and then 9, and then 8, and then 7, and then 6, and then 5. Okay, so we have 10 spots that we could put the first head in, and then we have 9 left where we could place the second head, and 8 left after that to place the third head, and so on. Okay, but remember that these H's, these heads, are you know, interchangeable. They're identical, so we actually have to divide this by 6 factorial, which is the number of ways to arrange the heads. Okay, so 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Okay, now I can also write this, because we've got 6 heads, that means we have 4 tails. I can actually write that as 10 choose 4. Okay, because I can either I can either choose 6 places to put the 6 heads and then fill the rest in with tails, or I can choose 4 places to put the tails and then fill the rest in with heads. And these 2 numbers, 10 choose 6 and 10 choose 4, should be the same, right? So 10 choose 4, if we were placing the tails and then filling the rest in with heads, then you know, we're looking at 10 times 9 times 8 times 7 all over 4 times 3 times 2 times 1. Okay, and you could see, you know, just by, if I cross out that, you could see they're exactly the same, right? Because once we simplify it down. And let's see, let's go ahead and calculate this out. So 4 times 2 is 8, and then I can divide the 9 by 3 and get 3. So we're looking at 30 times 7, which is 210. Okay, so there's 210 ways to get 6 heads. Alright, so we can continue working through this, and we can do 10 choose 7, which should be equal to 10 choose 3. Now I like to calculate 10 choose 3 more than I like to calculate 10 choose 7 because it's, the simplification's already done for me. So it's 10 times 9 times 8 over 3 times 2 times 1. Okay, so I can make this a 4, and I can make this a 3, so it's 12 times 10, which is 120. Okay, and then 10 choose 8 is the same as 10 choose 2, which is just 10 times 9 over 2 times 1, which is going to be 45, and 10 choose 9 is the same as 10 choose 1. Okay, so if we have 9 heads, then then we just have one tail. So it's a lot easier just to place the one tail, and you got 10 spaces where you could put the tail. So that's just going to be equal to 10, right? And then finally, 10 heads. There's only one way to get that, so that's a 1. And now if we add all of those up, so 210 plus 120, that's 330, plus 45 is 375, 385, 386. If I add all those up, I get 386 ways, okay, of getting more heads than tails, okay, because I can get 6 heads, 7 heads, 8 heads, or 9 heads. But I'm actually going to show you a little easier way to do it. Now that I've shown you the long way to do it, there's a little bit easier way, and it uses complementary counting and the fact that it's just as likely that you'll get more heads than tails as it is that you'll get more tails than heads. Okay, because there's only 2 outcomes. So if we look at these 10 positions up here, then we have 2 choices. We can get a head or a tail for the first flip, and we can get a head or a tail for the second flip, and a head or a tail for the third, and the fourth, and the fifth, and so on, all the way to the 10th flip. So we can calculate the total number of ways that the flips can come up by taking 2 to the 10th, and I happen to know that that is 1,024. That's a good one to remember. Okay, so I know that 2 to the 10th is 1,024. And that's the total number of ways that these heads and tails can come up with 10 flips without any restrictions. Okay, so sometimes we're going to get more heads than tails, sometimes we're going to get more tails than heads, and sometimes we might have the same number of heads and tails because we could have 5 heads and 5 tails, right? So what I'm going to do, there's that case in the middle where we get 5 heads and 5 tails. So if I can actually calculate the number of ways that you can get 5 heads and 5 tails. That's easy, right? Because that would just be 10 choose 5, right? Which is just going to be 10 times 9 times 8 times 7 times 6 all over 5 factorial. 5 times 4 times 3 times 2 times 1. Okay, 3 times 2 times 1, that'll cancel with the 6. This can cancel, it'll be a 2, and I can make this a 2 as well. So what do I've got? I've got 18 times 14, right? So 18 times 14, let's see, that's 32. 4, 7, 18, so 252 ways that we can get 5 heads and 5 tails, okay? And so let's subtract that because I want more heads than tails. I don't want equal number of heads and tails. So I'm going to take 1,024 and subtract 252. That gives me, what, that's 772, right? And then I know this is the case where we have more heads than tails, and more tails than heads, and I know that it's equally likely that I'm going to have more tails than heads as it is I'm going to have more heads than tails. So I can just divide this by 2. Alright? And lo and behold, what do you get when you multiply or divide 772 by 2? You get 386. Alright? So either way we get the same thing, which is good because that verifies that we probably did it right. So there's 2 ways. One is to look at all the cases, 6 heads, 7 heads, 8 heads, 9 heads, 10 heads, and how many ways that you could get each of those cases. Okay, you have to understand how to compute combinations, and it's also good to understand the symmetries in combinations, and know that like 10 choose 8 is the same as 10 choose 2. It kind of simplifies your calculation for you. And the other way that we did it was to look at all the possible ways that the heads and tails could come up, and then subtract out what we don't want. Okay, we don't want 5 heads and 5 tails. All right, and we also don't want the cases where it's more tails than heads, and we know that it's equally likely to get more tails than heads as it is to get more heads than tails. So we can just divide. Once we get that 5 heads, 5 tails, subtract it out, we can divide it by 2. All right. Now that this explanation, assumes you know some about combinations. So you want to study combinations if you didn't quite understand this explanation.